All right, so on this homework, we are doing word problems in advanced graphing. I think the word problem I will do is the second one, and I'll only help with part of it, making sure you get the function set up. A shoe store has fixed expenses of $18,000 per month. Each pair of shoes they sell has an additional expense to the company of $30. Write a function c of x, the company's average cost per shoe over the course of a month if x shoes are sold. So, the average cost per shoe is the total costs divided by shoes. And the costs are, well, there's $18,000 plus each pair of shoes they sell is going to cost them $30, so it's $30 times x, divided by the total number of shoes, which is x. X is the number of shoes. So c of x is going to equal 30x plus 18,000 divided by x. And that is our function for the average cost per shoe. We take the total cost divided by the number of shoes, total cost per shoe. On the back, we've been graphing these things. I'm not going to do this whole thing for you, but I will look at one thing that's different. The new thing that's different is the horizontal asymptote slash slant asymptote. And in this case, what we're looking at is we're looking at the limit as x goes to infinity of f of x. That's where the horizontal asymptotes and slant asymptotes happen. And in this case, we've got as x goes to infinity, we have x cubed over x squared. These other terms don't matter very much because they're dwarfed by the size of the biggest degree term, which is x. Now as x goes to infinity, x goes to infinity. And what that tells us is the end behavior is going up to the right. It's not going to get closer and closer to some horizontal asymptote. It's just going to keep growing. Because the degree on the top is bigger, what we can do is we can do long division to see exactly where the asymptote is going to be. So let's say x cubed plus 2x squared minus 3x divided by x plus x minus 2. X squared plus x minus 2. And so x squared goes into x cubed, x times x squared is x cubed plus x squared minus 2x. Subtract x cubed minus x cubed is 0, 2x squared minus x squared is x squared. 3x minus 2, it's minus negative 2x, so it's minus x. Negative 3 plus 2 is negative 1. And now x squared goes into x squared one time. That's x squared plus x minus 2. I guess I should put a plus 0 here so I actually have something to subtract from. And this is 0. This is negative 2x plus 2. So what we've got is f of x can be rewritten as x plus 1 plus negative 2x plus 2 divided by x squared plus x minus 2. And what's happening here is now the degree of the denominator is bigger than the degree of the numerator. And so as x goes to infinity, this will go to 0 when x gets very big. And so as x gets very large, this function gets closer and closer and closer to the line x plus 1, which is a linear function. So we've got this asymptote at x plus 1. And so we knew we had this in behavior here. And so what's going on is we're going to be going towards this line as x gets big. We could cross this line in the middle, but as x goes to infinity and negative infinity, we'll be following this line. I don't even know what side of the line we're on. We'll have to see what how the numbers work out. But the slant asymptote, it's not a horizontal asymptote, is y equals x plus 1. As x gets closer and closer to infinity, the y values get closer and closer to x plus 1. So that's what's going on there. There was a slightly easier way to do this, which is that if we had factored this first. So I'm factoring the numerator. This is x times x plus 3 times x minus 1. And factored the denominator, x plus 2 times x minus 1. And we canceled it. You'll notice we found our hole. at x equals 1, but we could have multiplied back out and done x squared plus 3x divided by x plus 2 and done long division on this. It still would have come out to be x plus 1, but with a smaller number of terms. That might have been a lot easier to do. That's all I'm going to do on this homework. If you need help, come to tutoring. You've got a lot of tests over the next couple days.